Fluorescent non-disassembly method. The principle of this method is as follows. A special fluorescent dye is added to one of the heat exchanger circuits, where it distributes evenly throughout the system. Then, working pressure is applied, and the heat exchanger is held under these conditions for 30 minutes or slightly longer. After that, the unit is inspected in a darkened room using an ultraviolet lamp. At the leakage points, the dye glows, allowing precise identification of defects. To detect internal leaks, a fluorometer is installed on the other circuit, which monitors changes in fluorescence intensity. The advantages of this method include high accuracy, which allows the detection of even the smallest leaks invisible to the naked eye. Clear visual indication. Leaks are easily identified with the help of a UV lamp and fluorometer. Standardization. The method complies with an ISO standard. The disadvantages of this method include high cost. The method requires expensive equipment and the fluorescent dye itself is costly. Labor intensity. The process demands the preparation of special conditions. Limited accessibility. It requires specific liquids and a UV lamp capable of emitting radiation with an intensity greater than 0.8 watts. And of course, maintenance. After the test, the heat exchanger must be flushed to remove any remaining dye.
Serhi, could you please tell me how difficult it is to remove the dye after this type of test?
No, it's not difficult at all. A standard CIP cycle handles this task very well.
But a CIP cycle is required after any type of test anyway, right? So basically, this factor doesn't really affect whether it's considered an advantage or a disadvantage.
Yes? The only thing is, if there are external leaks, and they're large enough, such leaks will be visible on the outside of the heat exchanger.
Leakage?
Yes, just minor leakages. So they simply need to be removed, rinsed off with water, and that's it.
Ihor, could you please clarify something? We clearly understand that this method, with a fluorometer, detects even the tiniest leaks thanks to the fluorescent dye. But what makes this method preferable compared to the others? I mean, we're not only comparing it with hydraulic or air testing anymore, but also with gas-based methods like the hydrogen and helium tests that we'll cover later. So what are the key advantages of this method over the others?
Well, here I would rather refer to the disassemblable fluorescent method. It is preferable because it truly allows for the detection of fairly small leaks, typically around 30 microns, and enables visual identification of both the type and the exact location of the leak. As for the non-disassemblable fluorescent method, I wouldn't say it has any clear advantages over the gas-based methods.
And what if we compare it with simpler methods? For example, let's say someone in our audience is wondering, I'd like to understand how this method compares in effectiveness to gas-based testing. So, are we correct in saying that, from your experience, the non-disassemblable fluorescent method doesn't really offer any significant advantages over gas-based methods?
Even from a purely theoretical standpoint, when comparing gas-based methods, like helium or hydrogen testing, we're dealing with the smallest molecules possible. So by definition, it's difficult to compare them with any other method. They're essentially in a league of their own.
There's also the fluorescent method. Yes, the disassemblable one. So in total, there are two types of fluorescent testing. Basically, both methods operate on the same principle. After the heat exchanger is fully disassembled, a special dye, also called an indicator, is applied to the plates. This dye penetrates microcracks. The reverse side of the plate is then treated with a developer, which makes the invisible cracks visible through capillary action. In the photo, you can clearly see the areas where the dye has seeped through to the opposite side. The main advantages of this method are its high precision, allowing detection of even the smallest leaks, and its strong visual clarity. The results are immediately visible to the eye. There is also an ISO standard for this method. However, one of the main disadvantages is that after the test, new gaskets must be installed in the heat exchanger. This significantly increases the overall cost of the method, since new gaskets are quite expensive. Labor-intensive process. The test requires full disassembly of the heat exchanger, and afterward, it must be completely reassembled. Limited accessibility. The method requires special testing fluids. Long testing time. The process can take a very long time. At some facilities, it may even stretch over several days due to the large amount of work involved. And finally, maintenance, flushing is required after this test. And the second disassemblable method, The penetrant method, I'll explain it right away as well. The tests are identical, it's just that this one uses a UV lamp and penetrant dye. The tests are identical, it's just that this version uses a UV lamp and penetrant dye. So, the heat exchanger is also disassembled, and a special dye is applied. Then, the plates are dried for 20 to 30 minutes, and after drying, a UV lamp is directed at the painted side of the plate. At the damaged areas, spots appear that glow under ultraviolet light. So, the image shows an example of what it looks like, a clear visual representation and an indication of a crack. Both methods are identical, the only difference is the type of dye used. But in this case, a UV lamp is also required.
Serhai, thank you very much. As far as I can tell, the main difference compared to the previous methods is the high accuracy. In your experience, does this high accuracy mean 100% identification? Because I fully understand that after disassembly, the identification is 100% guaranteed.
Yes, this method is mostly used after it has already been confirmed that the heat exchanger has a leak, specifically an internal leak, and it's necessary to determine which plate is causing it. That's why the unit needs to be disassembled, and this method applied.
Got it, thank you. Ihor, could you please tell me, from your experience, I've heard that some companies choose the fluorescent method as their only testing method. So, when they need to check equipment for leaks, they do it during a scheduled production shutdown, fully disassemble the heat exchangers, replace the gaskets if necessary, and then perform fluorescent testing across the entire heat exchanger. And have you come across similar approaches? That would be my first question. And second, based on your experience, what do you see as the main advantage of the fluorescent method? And if there are any additional drawbacks you've encountered in practice, we'd really appreciate it if you could share those as well.
Indeed, some companies have historically used the fluorescent method, specifically the disassemblable version, as their standard. This approach is justified when each test is intended to provide precise leak detection. In other words, when the goal is not just to confirm the presence of a leak, but to determine its exact location and nature. However, I wouldn't say this approach is justified in all cases because, as mentioned earlier, it is often more effective to first perform an integrity test without disassembly, using a more gentle method, and only if a leak is confirmed, proceed to locate it and determine its characteristics.
Thank you very much. Serhi, I have a question about the dye, based on your practical experience working directly at production sites. When we use penetrant dye, how much time does it actually take to wash it off afterward? Let's say we've completed the test and identified the leak, but then we need to remove all the dye and reassemble the heat exchanger. How much time is usually spent on removing the dye and completing the reassembly?
Well, that mostly depends on the size of the heat exchanger. The dye itself is washed off using a standard CIP cycle. If we're talking about a large installation area, then yes, it takes more time. Also, during dye application, you'll definitely need to use some kind of distributor to ensure proper coverage. The area needs to be sectioned off and covered with protective materials so that the dye doesn't get onto surfaces where it could stick. Because penetrant dye gets absolutely everywhere. It seeps into all surfaces. And if it's additionally colored with a pigment or dye, it becomes nearly impossible to remove.
So, preparation requires setting up and organizing a dedicated work area.
Exactly. The dye is easily washed off the plates, but preparing the surrounding work area takes a significant amount of time.
Okay, thank you.